We already discussed how to import data using the right mouse click and the import wizard. For the same purpose, we can use the function UIimport. It's providing the same functionality, with the only difference that we can call it as a MATLAB function, choosing the file, and use the import wizard exactly the same way as before. Now we have the data inside MATLAB workspace. So if I double-click on the variable, I can see all the data content in the variable editor. And now, if I try to plot the variable, I see that the graphical representation is not what we expected. Why is that? In MATLAB, the data will be plotted column-wise by default, not row-wise like, for example, in C. So that's why we have this data set in the column 1, and then in the column 2, 3, 5, and so on. It does not help to analyze the imported data, as you see. How can we force MATLAB to plot the rows? We can provide the data to MATLAB for plotting in another, transposed way. We can use the plot function, and we can transpose the data with apostrophe. So MATLAB will now interpret the data as 2 columns and plot it the way we would expect. Let's see what these 2 columns are. I call the new variable my data. It is equal to data, transposed. And now we see that we get 2 columns, right? So if I double-click on my data in the workspace, we receive 2 columns. We can choose all the data and plot it, and then we have exactly the same view as we want. So this is a satisfying result, and now we see that MATLAB works column-wise and not row-wise. So let's discuss what we can do with this graph. In our case, we want to have some kind of a description for this plot. We look for some expressive names for the axes. And we wish a nicer way to show all these dots over here with markers for all the data points. Look, now the data is displayed as an interpolated line, and all the dots that we have in the data set are just connected with the line, but we want to see all the single points represented by markers. And we want to see the legend for both this and the other data sets, explaining something like, this is the measurement set 1 and measurement set 2. So let's do that. The easiest way of doing this at the beginning is to use the plot tools provided with MATLAB. I can select every object as you see, and the objects in MATLAB have different settings that can be manipulated. So if I select the line, I get access to different settings than if I select the axis. All the elements in MATLAB graphics are parameterized objects. Now I choose the first line and select this blue color for it, and I want to use some kind of marker, and this marker should be red. Let's see what we created. It looks better. And now I select the green line, and I want another marker. I choose the diamond. And this diamond should be yellow. Let's see the result. Looks pretty satisfying. So now I want to have legends for these data sets. Both lines have the display names that we can change. And now I call this one the measurement 1 and the other one the measurement 2. We see that the names of this data sets were changed in the plot browser, and now we have a button to display these names on the axis. Now, if I click on the axis, I have the opportunity to change the labels. We type temperature in centigrade for axis Y, displayed over here now. The label for axis X will be time in minutes. Looks good. And then, we add the title. It's our experiment data. Just look at this beautiful result. So I can close all these windows now. And this plot is now good enough to give it to customers. And if we want, we can even generate the MATLAB code for this plot, which will reproduce the plot settings with other measurements. Just click on that Generate Code button. We generated a MATLAB file that actually reproduces all the functions that are needed to generate exactly the same kind of a plot with all the predefined markers, colors, labels, and a title. That's pretty neat. If I close the plot, save the generated MATLAB file with the name Create Measurement Data, and execute it, something goes wrong. So let's see why it happened. Alright, we did not provide the data for the function, and the called function name is incorrect. We shall call the function by the name Create Measurement Data, and not the default Create Figure. And MATLAB asks me to fix it. Now the function name is corrected, and we have to provide the data for this function. Call it as a function, and provide exactly the data that we need. It looks a little tricky, don't worry. We will cover MATLAB scripts and functions in detail later on in this course. But now we have exactly the data that we wanted to plot, and now we have a function that we can give to other people or reuse it in a project to plot it. We were able to import data into MATLAB and to plot it. Now let's discuss how to export data from MATLAB. There are a lot of functions in MATLAB available for this purpose. Look at this screenshot from MATLAB documentation. To open the MATLAB documentation, you can just use the doc function in the command window or use this help button in the menu bar. You can go over to the functions in MATLAB directly, go to MATLAB Functions, Data Import Export. See how many functions are available for you to interface binary files, text files, and Excel spreadsheets. And if you look into the documentation articles, you will discover their simple structure, which is easy to navigate. At the top of each help article, you have the name of the related function with a short description and the syntax of it, including every instance of this function. If you do not fully understand the function description, you can scroll to the bottom of the article and see and execute some examples. Let's examine how to write into Excel file. So let's just use one example from the MATLAB documentation. I copy the example code, go to MATLAB command window and execute it. MATLAB is creating the variable d as expected. And now we have not only the variable d over here in the workspace, but also the test data to Excel file. Let's explore the content of the Excel file. This is what was created in the first step. These brackets help us to create the cells. And in every cell, we put some kind of data. For example, in the first row of the cell vector, we put the time and the temperature for the names of the columns, and underneath there are some time values. Okay, this is the first line of code that we have over here from the example. And in the second line of code, we write this data to the Excel file with the name testdata2.excel, the file over here in the current folder. Then we see that the data will be written into the Excel file without any offset, beginning from the cell number E1. So let's explore it. If we double-click on the Excel file, we will see that the import wizard will try to import all this data into MATLAB, and this is not exactly what we want to do. So let's right-click on the Excel file to open it outside MATLAB. Now we can see that the data was written exactly in the way we wanted, namely from the cell number E1. That's amazing, isn't it? So now we can reuse this simple piece of example code and write our data into Excel. And this is exactly as simple as reading data from text or Excel files or other formatted files. In MATLAB, there are even some low-level functions to read binary data if it is formatted or if you can explore it and understand how the data are formatted. So now let us discuss the shortcuts for better usability. As we already discussed, the CLC command is used to clear the command window, and the clear command is used to clear the workspace variables. Those are two commands that we use pretty often, and that's why it would be nice to have a shortcut for it. MATLAB provides a shortcut bar over here, and I use it a lot as it saves time during development. So what you can do, you can right-click on the shortcut bar and create a new shortcut. We will call our shortcut CleanMe. This will be the name on the button. And here, we will use the CLC and the clear commands. And we will choose the MATLAB icon. If we click on the Save button, we get this nice button, which will help us to clean the command window and to clear the workspace. You will get more information on how to create shortcuts if you click on the How to Add button. And in the next chapter, we will discover all about the data types in MATLAB and what methods we can use to manipulate them.